we are going to do lesson 9 this week. So this one's going off of lesson 8. A lot of the things are like, they were the basis that we talked about in lesson 8. Now we're getting a little more complicated. So we're doing inferences for 2 samples this time. 2, raise the roof. And yeah, building off of last week where we talked about 1 sample, now we're going to talk about 2 of them, obviously. So that's why it's important that you understand lesson 8 so that we can move on to that. All right, and just a review of our 5-step hypothesis testing procedure. I just want to make sure you guys have this down because we do use this for every single sample that we do. And we want to make sure that every hypothesis test we do these 5 steps is just different for each different type. So I just want to make sure you guys have a good hold on these. So first one, we're going to check our assumptions and write our hypotheses. Then we're going to calculate our test statistic, which will be different for each one. Remember we have Z for proportions, T for means, that kind of thing. Then we're going to calculate our p-value based upon that test statistic. Then lastly, we will make that decision based off the p-value in order to state a real-world conclusion as to what that means in real life. So those are 5 steps that you'll see us go over and over again throughout these different procedures. So here we're talking about 2 independent proportions. So we're talking about 2 proportions that, remember, paired means that they're dependent on each other. These are going to be independent. They don't affect each other. And okay, so when we're talking about these, this is our first step. We have to make sure these conditions are met. So our n1 times p1 has to be greater than or equal to 10. And then n1 times 1 minus p1, it has to be greater than or equal to 10 as well. And literally the same thing, the same conditions have to be met for your second proportion group. So that's why, I mean, if you remember from last week when we were talking about 1 sample, we would just basically have this first equation. We didn't really have the subscripts there. But for the second one, basically, it's just now because we have 2 different ones. So that's the main difference there. And then also we have our standard error down here. It's the same standard error that we've been using for proportions, except the main difference here is that we're going to have 2 different parts of the equation underneath that, what do you call it? Underneath the square root, okay? So we have our first sample here, second sample here. And then here's our confidence interval. And this stuff should look pretty familiar to you guys. I mean, the main difference between doing 1 sample and 2 samples, or like 2 proportions, is that we just are basically adding a second part to every single part of the equation except for the multiplier. So as you see here, we have a P2 in our sample statistic, and then we have a P2 over here in our sample statistic. So that's the main difference there. You just want to make sure that you kind of understand. That's why it's important to understand the basis of one proportion, because the main difference here is that when we have 2 proportions, we just basically add this P2 in there. So same idea with our confidence interval. We do have our point estimate plus or minus our multiplier, which is Z star for our proportions, and then times our standard error. And then to recall, something I often see that students struggle with is that, remember that our multiplier times our standard error is going to be our margin of error. So keep that in mind. And yeah, so that's just, it's basically the same thing we've been talking about, except it has to do, it involves 2 different proportions instead of 1. And then, so, okay, so now if we go ahead and do our 5-step hypothesis testing procedure for 2 independent proportions, we'll start at the first one. And remember when we talked about n times p and it being successes, and then n times 1 minus p is going to be failures. Same idea as here. So minimum of 10 successes and 10 failures for each group. So this means that we have to have n times p is greater than 10, and then n times 1 minus p, that's our successes and failures, has to be greater than 10. What am I doing? 10. And remember, this goes for P1 and P2 because we have 2 different proportions. So, and then once again, I won't go too far and deep into this. This is just basically for your reference to understand these different, like what you would write the null and alternative hypotheses as. So your null and alternative will just here. Remember, we would have like our P equals 0, P equals 0 for these different for our null hypotheses. But in this case, we're having our P1 and P2. So we have 2 different proportions for each of them. So, but still, the same thing is down here, that our type of hypothesis test is going to be the same for each of these. If we're talking about different, because remember, this is going to be not equal to. And then this one's going to be greater than and less than, which is shown in our alternative hypothesis down here. But the type of hypothesis test is going to be the same for any type of, like this row will be the same for any chart that I put up here for our testing assumptions there. Our second step, calculate that appropriate test statistic. Once again, this is going to be Z for proportions, and then make sure you have that second P value in there, our P hat 2, so our second sample proportion, and our standard error will be on the denominator there. So that's our test statistic for 2 independent proportions, because we have 2 proportions here in our sample statistic. And then our last 3 steps, which I'm sure you guys are pretty good at by this point, you're going to determine your p-value, decide between the null and alternative, and then state that real-world conclusion. And then this is just the extra information about those steps specifically. So you're going to determine that p-value associated with whatever your test statistic was. And then, we specify here was the Z distribution, what we used to find the p-value. And then decide between the null and alternative. Is our p-value less than alpha? If it is, reject the null. If it's greater than, we're going to fail to reject. And then lastly, state that real-world conclusion, because, statistics is applicable in the real world. Believe it or not, you'll see it a lot more after this class for sure. But since it is applicable, we want to make sure that we're able to decide between the two, and then make a conclusion about that, what it actually means. Okay. Okay, so now we're going to talk about 2 independent means. So we're switching gears. We're talking about quantitative variables now, 2 independent means. And then this is the equation that we have for confidence interval for 2 independent means. And just to review what these different parts of the equation mean, this is going to be our sample statistic. And then we have our multiplier, which is in terms of our means, we're going to have our, that's going to be a T star. And then this right here is our standard error. And keep in mind, we do have 1 and 1 and then 2 and 2, because we have 2 independent means, which is why we're having those different subscripts. So don't make this too complicated. I remember when I took this class, this equation looks super scary, but all it's doing is adding in a different mean, like a separate, because we used to only use 1, but now we're using 2. That's all it's doing. Same idea, just adding in a separate mean there. All right, and then we'll go ahead through the steps again for hypothesis testing for 2 independent means. So our first one is going to be check those assumptions, and then remember, according to our central limit theorem, we had to have data that was independent, and both those population sizes had to be normally distributed in order to assume that we can use our sample in order to make an inference about our population. And we always said they're about greater than or equal to 30 in order for us to go ahead and do that. And yeah, once again, we do have our table down here, and you can see here that we have our mu1 equals mu2. Another way to write this, which has helped a few people that I've talked to, is, oops, didn't mean to do that. This could also be mu1 minus mu2. Mu2 equals 0. It's the same thing for all of these. So it's just saying, because if this means that if they're the same thing, obviously this would be like if they're both 1, it's obviously going to equal 0. Like 1 minus 1 is 0. So in this case, it's the same exact thing, just written in a different way. So like I said, I always try to show you guys different ways of writing things, because sometimes it makes sense in different ways to everyone. So that doesn't make sense to you, and the other one does, don't worry about it. But that's just another way to think about it, if that helps you. And like I said, these are our types of hypothesis testing is always going to be the same. For our two-tail, we're going to have our not equal to, right tail greater than, left tail less than. So that's that there. All right, so now we're going to move on to our step 2 of the hypothesis testing. So we're going to go ahead and calculate that test statistic, which our test statistic is going to be T in terms of our for means. So remember, we use Z for proportions, T for means. And like I said, don't be confused with this. So basically, when we used to do one sample, we would basically have this part of the equation. This is all we would use. So all that independent means for 2 independent means is we're just adding this part of the equation in, and then that's going to give us, for when we're talking about two independent means. That's all that that's saying there. So we have our test statistic for two independent means, and that's how we find our t test statistic there with this equation. Alrighty. And then last but not least, we do always have those ending three steps that are always the same. So we're going to, third one, determine that p-value. And in this case, remember, for proportions, we use a z-test statistic. For means, we're going to use a t-test statistic and use that to find our p-value. And then for the fourth one, decide between the null and alternative. Decide what you're going to do based upon our p-value if you reject or fail to reject. And lastly, go ahead and state that real-world conclusion based upon what you find in the fourth step for our hypothesis testing procedure. So 3, 4, 5, I try to keep them on the same slide because those are basically all the same for every single type of hypothesis test you're doing. The main difference is just going to be which test statistic you use to determine your p-value. So for our proportions, remember, we use our z-test statistic, and then for means, we're going to use our t-test statistic. All right. Oh, review questions. This is a shorter chapter. All right. Let's go ahead through these. So let's see. And this one's shorter because over the summer we we condensed the last chapter with this one. So if you can imagine, that was a very long chapter. This one's a little bit shorter because we did split them up this for the fall semester. So this one is a little bit shorter. It may seem a little bit shorter to you guys, but it's not something that's wrong. So let's go ahead and try this one. This one requires you to kind of do some calculations and just kind of understand those concepts. So this says, test whether the treatment is significantly better than a placebo at relieving pain. The patients were randomly allocated to the two groups, and the experiment was double-blind. Subscript 1 is treatment 1, and then subscript 2 is placebo group. That's what I have down here. And then, so I want you guys to find the relevant sample proportions for each group, and then our pooled proportion, which is this last one down here. So try to calculate these, and let me know what you think about them, and we will go over it. Yay! Great job, Hannah. Let's show them how to do it. So that's absolutely correct. So let's go through these. So remember, our first subscript, this is going to be our treatment group, and then our placebo is going to be 2. We're doing the proportion. Yes. Ooh. Jimmy said with ... Oh, okay. Okay, awesome. Yeah, because remember, it's asking, test whether the treatment is significantly better than the placebo at relieving pain. So that's how we know what we're trying to test there. So our P1, all we have to do here is 42 divided by 81. So that's going to be that relieve pain divided by our total. And then we'll get about 0.519. For P2, that's going to be our placebo, and then we're going to have relieve pain over our total, so 22 divided by 76, and then, which is going to equal 0.289. And then lastly, our pooled proportion is basically going to be our total that relieved pain, which is going to be our 64, and then divided by our total, like, people in general. So we're just going to do 64 divided by 157, which is going to come out to 0.408. Yay. Good job, guys. Woo, woo, woo. Proud of you. Okay. You guys clearly have a handle on that. But yeah, that's basically how we know, is that it says they're testing whether it's better at relieving pain, which is why we knew to use the 42, the 22, and the 64 there. So, awesome. All right. So this next one's going to be kind of a continuing question. So we'll start with this one. Like, we're basically going to go through a hypothesis test for a specific problem. So let's try this one. So using data from a study, we found a significant difference in the proportion of fruit flies surviving after 13 days between those eating organic bananas and those eating conventional non-organic bananas. If we are trying to test if the proportion of fruit flies alive after eating the organic bananas, which is our P subscript 0, and then is higher than the proportion alive after eating the conventional bananas, P subscript C, what would our null and alternative hypotheses be? So this one's just writing the null and alternative hypotheses. This is our step 1 of our hypothesis testing procedures. So go ahead and try this one out, and we will go over it. Woohoo! Awesome job, Hannah. That's exactly correct. I always lose my pen. Okay, so remember, our null hypothesis is always going to have a equal sign in it. So in this case, that would be that our proportion that of organic bananas, those eating after the organic bananas, and the ones that didn't, is going to be equal to each other. So that'd be P subscript 0 equals P subscript C, and then our alternative is talking about, we're trying to decide if it's higher than. So then that just means that our P subscript 0, let me write here, this is our null, this is our alternative, P subscript 0 is greater than P subscript C, because we are talking about it being higher. So this is going to be that there's some sort of change. And remember, we always assume that the null is true at the beginning, but this is going to mean no change. Oops. So that's what this is. So awesome. Good job. All right, so same question, but we're giving you some different information here. So basically the difference between this last question and this one right here is talking about 345 fruit flies. We're giving you the sample sizes are alive after eating the organic bananas, and 320 are alive after eating the conventional bananas. Both groups have a sample size of 500. So what is the test statistic? And I gave you the standard error here, so you don't really have to worry about calculating that. And then we will find that out. So go ahead and try this, and we will go over it. Alrighty, let's go over this one. Why do I lose my pen every single time? Doop, doop, doop. Well, let's. Oh my gosh, I'm horrible. 10. Alright, I guess I'll try to write this one. That's so lame. How can I lose my pen in like 30 seconds? It was on my lap. It's fine. It's fine. Okay. All right, so basically all we do for this one is remember for our z-score for test statistics, so remember a z-score for, or we use test statistic z for our proportions. We're just going to do our p hat 1 minus our p hat 2 minus 0, so basically don't need it, and then standard error of our null. So in this case, our p hat 1 is going to be 345 divided by 500, and then minus our 320 divided by 500 divided by our standard error, which is going to be 0.299, which I already gave you. And then if we go ahead and solve this out, we're going to get about 1.672. This is going to be our test statistic. Does that make sense how I wrote that out there? Yay! All right, cool. I believe we have 2 more, maybe. I don't remember. Okay. 2 more, yeah. All right, using the data from a study, we are looking to see if there is a difference with alpha equals 0.05 in the proportion of fruit flies surviving after 13 days between those eating organic bananas and those eating conventional non-organic bananas. Same question, same sample size and whatnot. So if our p-value is 0.47, what's our conclusion going to be? So go ahead and decide on this one. You guys should get this one pretty quickly, I think. Good job, Hannah. So here in this case, if we look at this, here's my annotate. Okay, so if we look at this one, our p-value is greater than our alpha, which is also known as this. So we have 0.47 is greater than, a lot greater than our 0.05. So we're going to fail to reject the null. So that means that we have no evidence of a change. So good job. This will be our conclusion, is that we have no evidence and we're failing to reject the null, and we're going to continue to say that there's no change. All right, find the standard error of the distribution of the sample mean. So what I couldn't figure out how to do the the equations here. It was giving me some struggles. So it's going to be x bar 1 minus x bar 2. That's what this is saying up here. So we have samples of size 27 from population 1 with a mean of 6.4, standard deviation of 3.2, and samples of size 36 from population 2 with a mean of 7.2 and a standard deviation of 7.8. So I'm asking you to find the standard error of this distribution of these sample means. So try to do this one. If you're stuck, obviously let me know and we will go ahead and try it out together. Oops. Ooh, I don't know what I just did there. Good job. So, all we do here, I know, Hannah needs to settle down. She's going crazy. Definitely knows what she's doing, so good job. So remember, we're going to have our S1 divided by, sorry, let me make sure this is, there we go. S1 squared divided by our N1, so our sample size is the first one, plus S2 squared divided by our sample size for the second. So this is going to equal our 3.2 squared divided by 36, or sample size, plus 7.8 squared divided by our sorry, this should be 27, and then divided by our sample size of 36. And this is going to come out to about 1.44. Does that make sense how we got that one? Woohoo! All right, so yeah, like I said, that's kind of a quick lesson. We only have like 2 subjects to go over for that. So yeah, we have our group reviews. I'm sorry, I didn't change this. Obviously, don't go to this website. Go to our sample whatever sample size or whatever, and then our next group review will be on Sunday. Obviously, I'll be there. Hopefully you will be too. Let me know if you have any extra questions. If not, give me your Penn State email, and that would be awesome. Yes, please. Don't do a ... like it's an issue. I would love to answer your question. I'm ready. Water. That's a good question. I've just decided that when I talk so much, like I've started to like my voice gets like, but yeah, so I've started to you know, do some, like my throat starts hurting. So yeah, I'm trying to stay hydrated. Here I am. But thanks, guys. Good question, Jimmy. That was a good one. Any other fun questions? You're very welcome. Have a great night.